when you combine electronics and fashion design, you can actually create wonderful and exciting things. Garments that are dynamic, sensing, adaptive, and various combinations of these. Yeah, and we increasingly see them on the stage, yeah, and on the catwalk. But how do you open up the eyes of fashion design students to make them aware of the creative potential? How do you get them excited, engaged, and involved with this area, which is, after all, a very strange hybrid? Well, this was the challenge posed to me back in 2010 by a colleague at the Department of Fashion Design in Shutian in Taiwan. They wanted me to run a 2-week workshop with their third-year fashion design students on wearable electronics. So at one level, this talk is about our journey to try and meet that challenge, how we started and evolved the workshop over 7 years. On the other, it's about getting sort of different and remote disciplines to effectively and creatively work together, which I think is a fascinating area in its own right, and one for which I think there's still much to research. Now, given the time, I'm just going to focus in on just a few particular issues. Now, the way I'll do that is I'll split the talk into 2 parts. Basically, sort of how we started and the first workshop, and sort of evolved it over the seven years, and then sort of also jump to today and contrast that with the original workshop, so you can see the differences between the two. So first, though, there's some context. Who were the principal people involved here? So first, students, third-year fashion design students, confident at garment construction and taking on design tasks. There were 2 very large classes of 30 students. Level of English was quite variable, and for attending and passing the workshop, they got certain academic credits. Then there was the fashion design department. They're keen to expose their students to new ideas about what fashion is, and really to push the students out of their comfort zone, and they're willing to take some risks to do that. And then, actually, before we go on to that, also, of course, I was involved in this. Why me? Well, between 1998 and 2004, I headed Philips's research activity on wearable electronics, where we brought together fashion designers, textile specialists with hardware and software engineers. And it was a hugely creative time, really allowing us to do some very nice fundamental work in what was then a nascent field. I think as a result of that, and actually other interactions with this particular institute, I've really become a strong advocate of the creative potential of these sort of disparate mixed disciplinary teams. So that's my involvement. So working with the fashion design department, we started to put our ideas together about the workshop, and we quickly agreed that an important element was that the students would do a design and make a garment with electronics, as a means of making it engaging and challenging. But how do we structure the workshop to achieve that? Well, let's take a closer look at fashion design and electronics. And if we do that, we notice that the differences between the two are really quite stark. How the respective disciplines, for example, relate to materials. For example, in fashion design, the materials are soft, flexible, robust, washable. For electronics, they're hard, rigid, fragile. One misplaced component or one wrong line of code, causes catastrophic failure. The languages of the disciplines as well are also vastly different. You're happy talking about toiles, draping, volumes, pleatings, gradings. And an engineer will talk about op-amps, oscillators, bugs, and PAs. So it's a vastly different world. So what we find is that if we look at the two communities, and the obligatory Venn diagram, of course, is that there's actually very little overlap between the two disciplines. So, given that, how should we sort of progress? So what we wonder, well, there are two ways we could possibly then progress in terms of constructing the garments. One is that the students could learn sufficient electronic skills to make a working garment for themselves. For example, learning some coding and some circuit design. So with guidance, they could effectively do it all themselves. The main issue here is that even with 40 hours of the workshop design, actually it would be quite limited what they could do because of the lesson or the burden of learning. And so we felt that may be insufficient to make it sort of exciting for them and keep their attention, and probably bog them down into a lot of detail. So as an alternative is to say that or instead of pulling them across to sort of being a polymath, an alternative would be to say, well, let's turn the workshop into a collaboration between fashion designers and engineers, because this fundamentally changes the dynamics of the workshop. Not least in that we have to find some friendly engineers. But with this change, a key part of the workshop then becomes fashion designers expressing their ideas to and establishing a dialogue with an engineer in a way that allows them to come to converge on a design. Because in this case we want to establish this improved dialogue, what we're trying to do in the workshop is essentially widen the area of common understanding, to get a better bandwidth between the two parties. Now in the workshop, time is always short, and we want to increase this area of common understanding as quickly as possible. One of the ways we chose to facilitate that was to introduce what we call the bridge role. That is, someone that's an expert in one domain, but also has sufficient knowledge in another domain so that they can readily interact with that other discipline. And for the first workshop, that was my particular role. So we have the bridge role. What then did we do in addition to that to sort of broaden, the common understanding? Well, in fact, you don't have to do anything radical then. I think we just basically did some lecturing, we had case studies, we had demonstrations, and we had some play. So, so on the first day, the students get to make a simple LED t-shirt, 4 LEDs and a battery. And interestingly, when the students finished, and they finished the design, they put the battery in and it lit up, there really was like childlike excitement that it actually all worked. So the students started the workshop, and the design brief was extrovert nightclub wear for 20-somethings. Okay. So, the teams of fashion designers, they worked with their engineer to complete their design. And on the final day, there was a sort of combination of a catwalk and a show and tell, where the students described their designs to the examiners, which was myself and several members of the department. And hopefully, I should try and get the video up here. So the video here is just 90 seconds, just showing a few clips from the final day and just a couple of the designs. So this is the final day workroom with the final attempts at getting everything working. Some people took a very avant-garde view of nightclub wear, I have to say, yeah. And this was the most extrovert of the extrovert ones, yeah. think the one more. This was meant to be like water coming down a window, which is one of my favourites. Yeah. Okay, right. So that was the workshop. After the workshop, we went through a postmortem with the department. What was the outcomes for that? Well, the underpinning element of collaboration worked. I think that was the most important thing. The students were able to produce some good designs, as I hope you could see. Overall, the department themselves were also happy with the quality of the garment designs. There was some concern initially that the focus on the electronics would distract from the design elements, but I think in the end they were happy with it. An unintentional surprise was that the workshop video got taken up by some blogs, so it actually got quite a lot of publicity, which the department again viewed positively. And an interesting one was that because we had a large number of students and because components cost quite a lot and we had a limited number of engineers, the fashion designers worked in teams of 3 and 4 with an engineer to produce their design. And this was actually the first time they had experienced sort of like teamwork or a team environment during their whole studies. And actually it was something that they felt very positive about and would have liked to have seen again. What didn't go so well? Well, 2 of the garments didn't work on the day. A lot of stressful time was spent debugging the garments. Many of the students left the construction till late, and then they found something didn't work, which put the pressure on the engineer to get a solution. And then, when they did find a solution, it probably needed garment rework as well. So everybody got very, very stressed. Sort of near the end. And I'll discuss this a little bit more in a few moments because it took several years actually to sort of sort this problem out. Other points, in focusing on the students, I rather neglected the engineers. They were all post-grad, so I assumed that they would have hit the ground running, but it took them some time to learn the technology that I bought, and also to establish a dialogue with the fashion designers. And the final thing, although the students liked the teamwork, the department didn't. And that's because, as a department, they were geared up to giving students individual marks. Each student needed to have their own particular grade. And of course, with a team, that's just not possible. In fact, we just gave each team member the same mark, for that. I think the department understood that was a practical limitation, but they were never really very comfortable with it. Okay, but the principal outcome was that the university decided that that was good enough for them to repeat the following year. So that was 2010. Let's wind forward to today, which was some 8 workshops later. How do things look today? Well, now the workshop is done with master students, typically 10 to 15 students. Back in 2010, there actually wasn't a master course at that time. However, once the department obviously was familiar with the workshop and there was a master program, then they felt it fitted well as a course option. Because we only have 10 to 15 students, that we can back to individual designs, so the department is again happy with that. Also, we now have extended design time. It doesn't all occur in the 2 weeks. In fact, the workshop itself is now 10 days, but the students get a design brief 2 months beforehand, and over the internet we iterate through various designs, so that by the time I arrive, there's quite a corpus of research being completed, and they have the elements of a design to start work on. And then finally, we've established a relationship with the National Taiwan University, so we've got a supply of engineers. There's never any shortage of volunteers, and it also gives some continuity, because usually when I run the workshop, 2 or 3 of the engineers have done the previous one, and so can sort of educate the newer engineers. But so the underlying sort of core of collaboration actually has stood the test of time. That hasn't changed. You can see lots of other things have changed, but that core element has stayed. But what about the issue I mentioned in the first workshop? regarding the excessive effort to get the garments working. How was that addressed? Well, I think it's an important lesson, and I just want to go through it in a little bit of detail under the banner of technology myth-busting. Now, many of the components that we use for wearable electronics now owe a great deal to the following wonderful trinity. This is Leah Berkeley, Lady Ada or Limor Fried, and Becky Stern. They made components like these, components, LEDs, sensors, that can be easily sewn into a garment. Basically, they've created a portfolio of garment-friendly electronics. So suddenly we had this wealth of componentry, but when people first start to use a new technology, myths can quickly established, particularly if they're shrouded in an air of plausibility. So let's take two components, let's say an LED and a battery, and I want to connect them in a garment. Then the perceived wisdom is that you should use this thing on the left, which is conductive thread, stainless steel conductive thread. It's soft as a thread, it's familiar to fashion designers, and of course most of which are happy sewing, very comfortable sewing. So it's absolutely obvious this is what we should use. And that is the myth. I was taken in by this sort of impeccable logic and duly unleashed it on my students. But really, this is not a thread, just a thread anyway. It has a dark side. It can really be a source of misery. Because unless you're actually highly skilled in using this, it's very easy to get a problem that's very difficult to diagnose. For example, the student has almost completed their design, it's all working well, they put it on their model, and the model moves in some way and all the LEDs go out. They move again, all the LEDs come back on again. So it's obvious that there's a connectivity problem. But if you just look at it, you actually can't work out where that is, And so it becomes a really drudge to sort of try and sort out the problem. The threads can also, little filaments of it can sort of shed off, and then suddenly, the garment shorts, the positive and negative get brought together, and again all the lights go out, but you can't see it because it's so tiny. So now I get my students to use wires. They're stiffer, they're more fragile, but and of course occasionally they break. But actually every student knows what a broken wire looks like, and so it's not a problem. But it took me 3 years to sort of realize this was the problem. In the second year workshop, I had a mix of wires and conductive threads, because at that point I was still assuming that it was me who was just not teaching this well enough. So I just think it's an important lesson. So in the early days of trying technologies, it's worth challenging conventional wisdom. Okay, so to summarize, you can get fashion design students excited about electronics and the creative potential. I think fashion design students and engineers can really work well together and actually do some really exciting things. But it doesn't just happen. I think it needs a lot of very careful thought about how these interactions are stimulated. It takes a lot of care and it takes time. You need to develop it over time. But I mean, mixed disciplinary teams can really be the crucible of tremendous innovation. But I think we still have a lot to learn. And and the other final point, of course, is that if you're thinking of using conductive thread, think twice. Okay, thank you very much for listening.